let's get into it. So Git, we got 40 minutes left, and we're hopefully going to cover everything we need to today about Git. Like, what the hell is Git? Like, you Google Git and not GitLab, I want Git. Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Okay. Sure, companies and projects using Git. Google, Facebook, Microsoft, Twitter, LinkedIn, Netflix. My God, they must be popular. Damn, that's a big chunk of people. So we're going to learn about using this today. We'll talk about labs. We'll talk about labs at the end. And how I'm gonna talk about it is by going through some demos. So, sorry, just my chair. With Git, we're going to talk today about the basics of Git, which is version controlling, and then the second part, which is teamwork, which we're not actually probably going to get through so much today. More so, we'll talk about that one next week. But before we go through these different steps of Git, let me just talk about what it is. So there's two big parts to Git again. First one is version control. Right, if you ever use like Dropbox or OneDrive or something, or just anything really, you know that like a problem is that it's not always keeping track of versions. Some software does, but a lot of software doesn't. So Git is something that allows you to kind of take snapshots in time machine on Macs, kind of like this, like take snapshots here and there so that at any point you can go and unwind and go back in time through history to bring your code back to a previous state. I mean, how many of you have ever been working on like a C program or something and you kind of have it working and then you try and add something or fix something and then you kind of get caught down a rabbit hole for a while and it's been 3 hours now and you realize it's all gone to hell and you just want to go back to what you had. Maybe you try and Control Z, Apple Z, undo, but the undo history is not long enough, or maybe you restarted your computer in the meantime so your editor doesn't have the history in the cache. Like, that's not a great way to program without, kind of keeping track of that history. So Git helps us keep track of the history. That's the version control part. The second part is the working effectively in teams thing. Have you ever tried to actually like code with someone else when you're like working on the same software, and sometimes even writing on like similar files, but you're like in different places? You're not together. It's not like two of you pair programming on one machine. This is like you working at home and them working at home. So Nayuki says, so it's like a group programming tool. Yeah, it is. It's a way where you can effectively actually work together. Because what's your alternative, okay? Dropbox, OneDrive, whatever the hell people use these days. Okay, you upload your code to Dropbox. And then you share your Dropbox link with your friend. And now you both work on some code files. Dropbox craps its pants. And it's like, hey, alright, too many people are touching this file. And then it gets grumpy. So it's really software's solution to version control and working in groups. There are other tools like Git. There's SVN, Mercurial and stuff, but Git is kind of the, I don't know, it's kind of like, you know how there's like different terminals? Like you've got your Unix terminal, but then you also have like your Windows command prompt, PowerShell and stuff. Like they're all trying to do the same thing. They do it a little bit differently. There are other tools like Git. Some companies like to use different tools. I don't think Google uses Git that much. I don't know. I had a friend tell me that they use something else. I don't know. But I know that like Atlassian uses Git. I know Canva uses Git. I just know some Sydney-based companies. Now, what's the difference between Git and then you hear these other terms like GitLab, or many of you have probably heard of GitHub, and then there's another one, an Australian one called Bitbucket. And if you like Google GitHub, you've probably all heard or seen of GitHub before. You've probably seen this logo somewhere around. Okay, GitHub. Ooh, How exciting. RoboCup, right? You guys have seen the soccer playing robots? These little thingies? Right, so UNSW has their own team. This is UNSW's team. That's Claude. You ever see Claude around uni? Give him a hug. I hear he loves hugs from strangers. They actually keep their code up on GitHub, right? So like you can actually go and have a look at some of UNSW's code from GitHub. There's the code. It's just floating around. What's the difference between GitHub and GitLab though, right? Like that's an interesting question, and we'll get to that. There's GitLab, GitHub. There's also Bitbucket, which is the Atlassian's one. Lots of different tools, kind of look the same. Richard asks, why don't we use GitHub for this course? I reckon most CSE courses use GitHub. We'll get back to that question. So GitHub is forum, Git is tool. That's different. Close. I think that's a large part of the way, definitely. So Git is the tool. Git's the software. GitLab, GitHub, and Bitbucket are really nothing more than nice websites that wrap around the engine. Because the thing is, Git is kind of like a command line tool in many ways. Just like, you work with Linux commands like cd this, gcc that. Like you think about VS Code. You know how in VS Code you have like a little play button or something where you click it and it runs like GCC on your code. It like compiles and runs it for you. It's like it's still using the same underlying tool, but it is it's a wrapper for it. It's an expression of Git in a way that's user friendly. An expression of GCC. So GitLab, GitHub, Bitbucket, they're all kind of the same tools. They just are Git engines with nice web interfaces. Now, I just want to quickly contrast these. So GitHub is kind of the biggest one, I believe, in the world. Acquired by Microsoft a few years ago. Bitbucket is Atlassian's tool. So Atlassian, the Australian-based company. That's their tool. Nowadays, they're much similar. Much more similar than they used to be. They used to be kind of quite different in the features they offered. But they're both kind of commercial tools. And I'm pretty sure that like GitHub is mostly free because I think Microsoft it's part of their broader plan. Bitbucket's quite cheap for people at scale. GitLab though is an open source tool. So one thing first you'll notice about GitLab. Notice how when I go to GitHub or Bitbucket, it's github.com or it's bitbucket.org. And even UNSW's code is still hosted on github.com. GitLab though, notice how it's gitlab.cse.unsw.edu.au. That's because GitLab is like a software package that you can download and run yourself. So CSE, our school, actually deploys and runs an instance of GitLab on our machines. So I don't know where this is running, but I'm pretty sure this is running inside of K17, the building on campus. I know some of you might not have even been to that building before. Isn't that a sad thought? But yeah, so it actually runs there. And why do we like to use GitLab? Like, if anyone's used other tools, GitLab is by far not the coolest of the three, right? It does all the same stuff, there's nothing wrong with it, but it's maybe just not quite as sleek as GitHub, or maybe it doesn't quite have the exact same features as Bitbucket. But it's open source, it's free, we can run it on the CSE machines, which means we can do a lot of cool things without having to worry about licensing with GitHub or anything else. So, because if you've seen in this course already, we deploy repos to your account, a whole bunch of other things, which is just very, very, very useful for us. Okay, so that's GitLab. Now let's actually play around with it. So first things first. Now you have repos, like you can see here that Josh has a repo here for Lab 1. I'm going to just make my own repo just for testes reasons, and I'll just call this one, I don't know, Lecture 01 21T1 test. Now you don't have to do this step. This is the one step you don't have to do. because your repos are already kind of created for you. So like if you go to projects, your projects on GitLab, you'll see far less than 1,000, and you'll see your ones there that are already created for you. So all of you have your labs created, your project's been created, and when you click on it, you'll get taken sometimes to pages like this. Now this is an empty repository. There's nothing in here yet. But there are some key steps to understanding Git. I think the first thing I want to make clear, and I'll again just use, actually I might use draw.io for this. Has anyone ever used draw.io? They renamed the tool. I really like it though. I don't know. One sec. To figure out how to do this. Yeah, sure, let's just do that. Sure. Why not? Sure. Take my money. Yeah, privacy something. Create new diagram, blah blah. Hello, Charles Knight. There you go. Hey Charles, I just found a random name on the thing. So the way Git works is you have to just think of Git as a tree, right? It's a tree of versions, and it's just kind of a big history tracking tool. So when I look at my Git repo, which is somewhere, have I lost it already? Where'd it go? Right now, there is the cloud. I'm going to call it Git Lab. And Git Lab is sitting up here. It's like got my repository, but it has nothing in it yet, right? It's totally blank. Whenever I say repo, I'm referring to like a project, right? So Git Lab is just a tool that lets you house Git repos or repositories, and those repositories are just organized like collections of code, projects of code. You know, it's like could be like a folder on a computer, but it's just a logical organization of things. So first thing I'm going to do, this code is on Git Lab right now, but I would like it to be on my own computer. And in fact, I'm going to use VLab because generally, like, I don't like to do things locally sometimes because students who struggle tend to use VLab, so it's good to like show things in VLab. So what I do is I go to this repo, I go to this clone button here, and then I copy the SSH part. Now this is assuming that you've already done lab 1 Git basics, right? Because there's some important steps in there that you have to do. I'm going to go to VLab now, and I'm going to maybe make a new folder called 1531, like this. I've made a new folder, we all understand that. And then I'm going to write git clone and then paste that. Now Git, the command line stuff, always follows the same patterns. It always starts with Git because that's the program you're running. You're using the Git program. And then it's followed by a command, which is like the action you want to do. Do you want to pull? Do you want to push? Do you want to clone? Do you want to add? Do you want to, like, all these different commands. They go on forever. And in this case, when I say git the program, I want to clone something. I'm giving it the URL, the address of the repository on GitLab that I want to clone and put on my own computer. Someone says, what's the difference between HTTP and SSH? That's a great question. They're just different ways of connecting. SSH requires setup, but is a lot easier to use because you don't have to enter your username and password every time. HTTP doesn't require setup, but you do have to enter your username and password every time you interact with the cloud. We give you instructions to use SSH because that is substantially more common because it's just easier to use. So yeah, SSH is the way to go. If you can't get it working, it's better to talk to your tutor or ask for help on the forum than it is to give up. Okay, so git clone and then that. So I'm doing the first step, right? Cloning. Yes, you can use both SSH and HTTPS. Oh no. Looks like I haven't set up my SSH key, which I don't think... Can I share it with you all? Is that bad? What happens if I share it? I guess that is bad. No, it's not, because you need my private key. Okay, that's fine. I'm like 99% sure that... well, let's just do HTTP, because you're going to see SSH in your lab, so maybe we'll try this one first. Okay. It is a public key. It's just I try not to make brash decisions on live stream lectures to hundreds of people. That's my only thing. So I'm going to git clone, Yeah, I know. And what you'll notice that when I git clone with HTTP, it prompts me for my username and password here, right? So I enter that. Oh no, what in God's name is happening? Does not like me today. Okay. We're gonna do the key thing. I'm sure it's fine. So in your lab, you'll see this. There's instructions there, but basically, if you generate a public key, which you can do, I've already done it, so I don't want to do it again. You can get a copy of it here. This is all in the lab. Don't freak out if you're freaking out. And I'm going to take that. I'm going to copy it, and then I'm going to go to GitLab. And up in GitLab, you can go to your profile. You can go to your settings. And you can go to SSH keys. It's all very straightforward, and you can type in there. There's my SSH key. I could call it hsmith on CSE VLab if I want. Doesn't really matter. Then I can click add key. And then it's done that, right? That's all you have to do. And now if I go back to my original command of git cloning with that, it should just work. What I've done here is I basically told Git, this is a machine you can trust. When you get a request from this particular thing, which is my CSE account, it's like, it's a trusted source. So there you go. One thing I will flag, you will see this error a lot on CSE machines. You can ignore it. X11 forwarding request failed on channel 0. A lot of students think this is an error or something's gone wrong. Literally just remove that line from your brain and interpret the message without it. And in this case, it just says cloning into 21T1 test, warning you appear to have cloned an empty repository. So what I've done here is I have now cloned it to my own computer. I will call this one VLab. So now there's a copy of the repo up on GitLab server, and there's a copy of the repo on my VLab machine. Now what I'd like to do is I'd like to add something to my repository. I'd like to do some work, right? And the first thing I'm going to do is I'm going to type in ls. You can see that it's actually made that folder for me, so I have to go inside that folder, right? And then inside that folder, I will see nothing, right? What's there? ls, nothing. What happens if I do ls-a? If you do ls-a, you see all the hidden files. And when I do that, you can see that there's actually this magical folder here called .git. You don't ever have to do anything with this file, but this is Git's secret folder that it keeps inside your repository where it keeps track of everything. So all the version control and other things, it's all stored in this hidden Git folder. That's where the magic happens, just in case anyone's curious. Now what I'd like to do is I'd like to create a new file. So I might type in gedit. I'll create a Python file, which we can, hint exciting tease for tomorrow. Gedit hello.py. I'll open a file. I'll write hello. There's a very, very simple Python file. Yes, all of these settings are written in Lab 1. It actually goes through it in excruciating depth. I'm more trying to just show you the general flow of it, if that makes sense. I don't expect anyone to watch it and go, oh, that all makes sense. It's more like, oh, there's the general pattern of it. I'll go away and spend some time looking at it. So I create a file, just like anything else. We know how to do that because we've done CSE courses before. I type in ls. The file now exists. Okay? So this file exists on my CSE machine. Now what git commands have we done so far? I'll keep a note of them just so we can record them. We've done clone. Great. The next one I want to show you is status. So when you type in git status in your folder, you get a bunch of information. And this one there's a lot to this command, so I can't explain it in 5 seconds or even a few minutes. But basically it kind of tells you what files have you edited, right? What's happened since you last took a snapshot of your work, right? And because I cloned this empty repository where there's nothing in there, it says to me, hey, you are all this stuff, and then it shows me a file that I have that is untracked. What does untracked mean? Okay. interesting. What that means is that GitLab is not interested in this file right now, right? Like your Git repository is not interested in that file. You need to kind of say, hey, this is a new file that I'm interested in you treating as part of my project. And to do that, the next command I do is called Git Add. When I Git Add, I'm saying, hey, I want you to look at this file and track this file. So I'm going to say Git Add, and then I give it the file name, hello.py. Now when I type in Git Status, I get a different message. Instead of saying untracked files, hello.py, it now says changes to be committed. So what this is saying to me now is that Git is looking at my files and it's saying that it's ready to take a snapshot. Now I've used this word snapshot before, but in Git language, it's actually the word commit, right? Because if you think about like a snapshot, it's essentially committing a moment of time to memory. That's what a photo is. You're committing a moment, right? Like commit is into to make a commitment. So if I want to make a commitment or like a commit to like where my code is at right now, the next thing I do is I write git commit. So git commit's the next one. Now when I commit, like I take a snapshot, one thing that I always need to do is I need to give some kind of description to my snapshot. I need to tell Git like what this is. And to do that, you follow the commit by a -m and then some text as a string. And in this case, I might say added first hello Python file, right? So again, to follow that, I'm using the Git program. I'm saying I want to commit or take a snapshot of my work with the message attached of added first Python file. Sarvesh asks, so now you're basically uploading your old code to the cloud before making any change? We're not quite uploading it yet, and I'll demonstrate that. So I did a commit. Now let's go back to GitLab. Let's see what's here. When I refresh this page, there's still nothing here, and that's because I've just made a commit. And what happens when I make a commit is it's like a little snapshot. So these rectangles here are snapshots. So what did I call this one? I said it's added first hello Python file. I might make that text a bit smaller. Right, so this is a commit that I just made. And it's on VLab. So it's the first commit. Now, if I want that to be back on GitLab, if I want to sync that with GitLab, then what I need to do now is I need to do Git Push, right? And Git Push is the next command. Now, what Git Push means is Git Push is a way of saying sync to the cloud, right? Some people, I think, get confused. Like, I don't like the word push because it kind of implies that it's really much more like a sync. Like, if you have files on one computer and you want to move them to another computer, you copy and paste them. Like, that's kind of what Git Push is doing. It's not really just jamming them up the butt of something. It's like syncing it. It's saying, I've got a version over here. I'd like you to sync up with my version. So push is in sync outward, right? So when I say Git Push, I usually get, depends what mood the thing's in. Yeah, okay, this is fine. So when I say Git Push, I'm saying I want to sync this to GitLab. So essentially what that means is that what I have here on VLab in my files, I would also like that to be on GitLab. That's okay, we're going to keep going through this. You guys have so many expectations on yourself. We've been talking about this for like 10 minutes and you're like, I don't understand it. And it's like, I know people who've worked with this for years and don't understand it. So like, give yourself some time. You know, don't stress. It's all good. We're going to talk about it today. We're going to talk about it next week. It's going to be in your labs. It's going to be part of your project. And you'll keep getting more and more used to it. It's just part of the process. Yuval says, it's like pushing all the changes from your local machine to the cloud, right? Yeah, so what this is doing is it's saying, I've got a bunch of commits here, and I want to push this to the cloud. So I just pushed it. I did Git Push. Forget branches. We're not talking about branches today. It's too complicated for the first lecture. I just refreshed the page on GitLab, and now have a look at this. I've got my file up on GitLab here. I can click on this. And there's the file. It's all there. Now let's do a few more things. I want to make another couple of commits, right? Before we do that though, let's have a look at GitLab. If I go to repository on GitLab and I go to commits, you'll actually see there's a history of all the commits I've made. It's just one commit right now. Just one, only one. And I can see that same history on command line, right, by typing in Git Log. A lot of commands, but we'll keep going through them again and again, and it'll make sense. And with Git Log, I can see the commit I've made. I can see that Hayden Smith made a commit on Monday, 15th of February at 1:39 p.m. and 44 seconds, and that was the name of the commit. Let's make another couple of changes to files, and we can have a look at it again. So I'm going to open up hello.py, and I'm going to add another line to hello.py called world. I'm going to close that file. I'm going to type ls. Still only one file, but when I type in Git Status, it tells me that here is the files that have changed. So what Git Status does is it shows you what files have changed since the last commit, right? And it's saying to me, hey, hello.py has been modified since the last commit. And if I would like to save this change now, because committing is like taking a snapshot of my work, right? So like I created a file, I took a snapshot of it, so we've got a moment in time captured in history, and then I'm making another edit to it, and I want to take another snapshot of that moment of time in history. I'm going to do another commit. Now, as you know, how you actually do this commit, which we just went through, is you first add it to say to Git, I want you to I want you to care about this file. That's where it goes from red to green. And then you say git commit, which is taking the snapshot. You give it a message saying adding world as second line, right? This message can be anything, right? It can be crappy, it can be a essay long, it doesn't really matter. I made a second commit. Now what I want to show you is when I git status again, what did I tell you that git status does? Git status tells you what's changed in your code since your last commit or snapshot. So when I click enter on status, it says nothing to commit because nothing has changed. Right? There's lots of fluff in these messages that you kind of learn to ignore for now. So what I'm going to do now is I'm going to make a third change. You notice I haven't pushed it to GitLab yet. So what I've actually just done here is I've just added another commit, which was adding world as second line. So I've now got a second commit on VLab, and I want to make a third commit. So I'm going to modify the file one more time. Hello.py. I maybe add an exclamation mark to the end, like that. So hello world exclamation mark. I type in git status. Git status tells me what has changed in my code since the last commit or snapshot. And that is, it says I modified hello.py. I would like to save the state. I'd like to take a snapshot again. So I git add hello.py, which tells Git to pay attention to it, which is why it's green now. And then I say git commit -m adding exclamation mark. And now I've added a third commit here locally. Like that. Now, here's the interesting thing, and I just want to try and contrast this difference between like VLab and GitLab. Like when I say VLab, I really just mean Git on VLab, right? Like it's like GitLab and VLab are different things. Don't be confused because they both have the word lab in it. Like GitLab is the actual Git software. VLab is just a tool for you to use the command line. So I should really even call this like Git command line on VLab. Right? So I've got these three commits here. Now have a look at this. On VLab, on GitLab, there's still only one commit. When I refresh this page, which is all of the commits, you can see there's only one commit. But on my own local VLab here, when I do git log, which we said before shows us our commits, you notice how there's three commits here? Have a look at them. I've got my first commit, added first hello Python file at 139. I've got adding world as second line at 144, and then I got add exclamation mark at 146. right? Someone's asked a good question, which I like, which is Chewy said, what's the point of committing locally instead of just pushing it straight away? So I think this comes back to a really critical idea about Git, which is that when you push from your code to GitLab, you aren't pushing files, right? It's not like OneDrive where like you have 10 files and you hit sync and it just sends 10 files up. What you're actually doing when you push to GitLab is you're actually sending commits. You're actually syncing the commits. You're syncing those snapshots so that both of you have a common history. If you think about Git as a history tracking tool, this becomes a lot easier because you can understand that what these commits are snapshots in time to track history. So remember how I said on GitLab, we only have this one commit, whereas on our VLab here, we have all 3 commits. Watch what happens now when I push. So I'm now going to push to GitLab. And what did I say pushes do? They sync commits. So I git push, it says blah, 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 done. And I go back to GitLab now, and what do you notice when I refresh this page? I now have these 3 commits here. Because what git push just did was it just, oh god, was it just synced the histories. So now GitLab and my VLab are like in sync. They both have the same commit history. Lots of you are going to ask questions about what would I do if I want to reverse an add, if I only want to commit some files. There's like 100 what if statements that I just don't have time for in the lecture. Generally, they're all Googleable, and we'll slowly cover them more and more throughout the course, or you can help your tutors. So like how to cancel the committed version. These are all questions that there's honestly 100 of them that we could go through, and we'll go through some more in the course. Paraf says, so git commit does not override a previous commit. These are all snapshots in history. So let's have a look at this. Let's have a look inside GitLab. I'll go look at these 3 commits. So I'll click on them. I'll open them in different tabs. And it's basically showing you what happened at each point in time. So this first one, it says that I added a line print hello. The second one says I added a line print world. And the third one says I added a line print exclamation mark. So these commits are kind of keeping a history. And if I go back to my files, you'll see that I have my hello.py file, and then inside of that is all 3 lines. So what Git does is that, think of it like it keeps track of your files, but it kind of also keeps track of all of the different steps that you took to get there, right? So even though it's got my like 3-line print thing here, it's also got the history in the commits of how I got there. So, you know, I got to my 3-line file because I just recently added a 3rd line, and then before that I just recently added a 2nd line, and before that I just recently added a 1st line. Right? I just want to have a look at another couple of these questions. Will this course cover how to handle conflicts? Yes, we talk about that more next week, and it's covered a little bit in the lab. That's okay. What else we got? They're all kind of... Git reset, that's another thing. We're not talking about that today. Can we just use GitLab to do implementation? Probably not, because like GitLab's just a web interface. It's like, you know, like, can you use Dropbox to write code? Not really. Like, you can open up files on Dropbox. You can maybe upload a file. Maybe you can edit it, but you can't, like, you couldn't do your assignment on Dropbox. It's like the same kind of thing. So yes. Now, some other couple of things. Just remember, you don't have to, I'll show you one more time. You don't have to only add 1 line at a time. You could add a few lines. Print goodbye. Print everyone. And then I'm going to add another file here. So I've just modified my file, and then I'm going to add another file called hayden.py, which is just going to print Hayden. sucks. Great. Now what happens when I click Git Status? When I click Git Status, when I type Git Status. It says to me, we see that two things have happened since your last commit, right? Because it's sitting here on this last commit. I can see that you've modified hello.py and I can see that you've added a file called hayden.py. And I'm going to say to Git add hello.py, because I want Git to care about this file for a commit. I want to stage it for a commit, it's called. And I want to git add hayden.py. Remember, git add gets files ready to be committed. So I've done some work now, and in reality, you don't commit that often. This isn't like a line-by-line thing. You might commit every few hours, you might commit once a day, all of that. And then I go Git Status. They're green now, so the green files tell me what's going to be committed when I type commit. If the red files won't be committed by default, Git adding them makes them go from red to green. And then I'm going to commit it, and I'm going to call it say goodbye, Hayden. That's a very dark message. Hayden added. So now I git commit that, and then what's happened there when I git commit is that I've added a fourth commit here. Right? Like this. It's called goodbye added or something. Hayden added. It was something like that. And then I do that. And this is just locally right now. So what does this mean? Like, what does this mean? Okay, well, right now, if my CSE account disappeared or I deleted all my files, then all of this would be gone. Right, all of that. So that commit I just did would have disappeared. And I would just be left on what's on GitLab. So GitLab is still that cloud thing. It's where it's all stored. But that's why we push, because we make commits locally. We do this work locally. And then when we're happy with the progress of things, we git push. And then git pushing syncs that up to the cloud, so that now you will see, when I refresh GitLab, I now have hayden.py and I have hello.py. Like that. So there are my multiple files. Now, in our last few minutes, something I just want to very briefly touch on, because we'll have to talk about this either more tomorrow or more next week. But it's also kind of common for people, like how Git works is like with different team members, is your team member who might be working on this repo too, and I'm just going to do this locally, like on my local Ubuntu thing. They might come along and say, I'd like to clone your repository. You can ignore this line. So now this second person, let's just call them Hayden, has just come over here. We just sync this with GitLab, by the way, so that's all fine now. They've come over and said, I want to clone your repository. And when you clone a repository, you don't clone a blank repository, you clone the whole repository. You get whatever's currently on GitLab. So this is like Hayden's local. So now me on my local machine, I can type in ls and I see those, I go inside the 21 test folder. Let me make this window just a tiny bit bigger. I go inside that folder and then I can open up hayden.py and I can be like, Hayden is cool. I can modify that. I git status. It tells me what has changed, what files have changed since the last commit, which is this commit. And then I say git add hayden.py because I want it to get it ready to commit. I git status. It's now green. I can run git status as many times as I want. It's just a check. And then I'm going to commit it. Git commit -n, the message is converted Hayden. When I commit it, on my local machine here at home, I have created another commit called converted Hayden or whatever it was. And this is nowhere else yet because I haven't pushed it anywhere. So this is my local thing. Git status, and now I can git push. And git push will push it up to the cloud. And I can see when I open hayden.py, it's been updated here. And when I look at the commits, there's now 5 commits. And you can see this one's come from a different person. I don't know why. I think it's because they're like set up differently. And that's kind of it. And you know what? If I'm working with someone else, let's pretend for a second that git command line on VLab. We'll just call that person Tay. Hi Tay. So that's Tay's thing. Then like if Hayden over here was to change the files and Tay wanted to get an update, like Tay's on my VLab right now for some reason, you see that Tay still only has those 4 commits. So what Tay does is has to pull, right? And this is the last command that's relevant here, is like pulling. So we said pushing is when you get your commit history and you sync it with VLab, with GitLab, sorry. So that's what I did here on the command line just before. I did this converted Hayden commit and then I synced it to VLab. And you can see now that Tay is behind. So therefore what Tay has to do is Tay has to say git, oh sorry, I'm on the wrong thing. Tay on VLab here has to say git pull, which is where they get the last changes. And you can see that it just says I've now updated that stuff. So now Tay has the latest changes. So couple of passing thoughts with this because we're coming very, very close to 2 o'clock. This is a taste of how Git works with multiple people on the same branches as next week, but you can kind of see that, you know, if you have a repo and your friend has a repo, you can both kind of push. Git's very complicated as well. It takes a lot of people months and months to learn, but it's super useful, and don't put any pressure on yourself. We've been talking about it for 40 minutes. You're going to talk about it more next week. We're going to talk about it in your labs. It's going to be part of your project. Your aim should be to feel comfortable with this by the end of the term. Do you know what I mean? And you'll slowly piece bits and bits together as time goes on. So, oh Christ, sorry. So don't put too much pressure on yourself. I'm dying. Lord. Okay. Must be sign that it's the end. I think I just swallowed my own stomach. So Richard says, one thing to notice is that git pull every time before you code. That's a really good point, Richard. So it's really good practice. Lord. It's really good practice. I've been yelling for 2 hours now. That every time you start working, you just do a git pull, right? That is like a syncing thing. So that's kind of a good habit, is every time you start your work, you just do a git pull. Now the last thing before we finish is I'm going to try a different... Does this work? Oh, what is that? Oh, that's not good. I would really like to try and see if this works. Okay, I don't know why it does that. Okay. So that's pretty much it today. Yeah, I'm the Ligma guy from Facebook. Heavens, that was a bad day. So that's pretty much it on Git. We're going to be talking more about it next week. If you feel nervous about something, if you're worried about something, everything on your mind you can sort out by either posting on the forum, emailing me, or getting sorted with your tutor this week. Okay, so if you have any of those concerns or any problems at all, it'll all get sorted this week. The course is designed to use that first week to get you into it. So head to your class this week. Happy to help. I like to help. Tutors like to help. Yeah. So thanks. And I'll chat to you all tomorrow.